Welcome back. Today we're going to talk about the volume of a sphere and of a cone. Okay, so the first thing I want to do before I even start getting into the lesson is I would like us to view a quick demonstration about how the volume of a cone is related to the volume of a cylinder. Okay? Okay, so what we saw from that clip was that the woman who was performing the demonstration had to fill up the cone 3 times in order to have the water fill up the cylinder of the same height. So given the same height, the cone was only 1/3 of the volume of the cylinder, okay? Or it took 3 of the cones in order to fill up the cylinder. So this is a visual of what's going on here. So given a cone of the same height, so this cone is, we're labeling this height 2r, and it's going to become obvious. Actually, we don't even need to label it. So given the same height, the volume of the cylinder is pi r squared h, and the volume of a cone is 1/3 pi r squared h. So it's 1/3 of what we already determined to be the volume of a cylinder. Okay? Now I want to talk about the volume of a sphere. And again, I'm going to have you watch a quick demonstration, then we're going to come back and talk about it. Okay, and what I wanted to pull out from this demonstration was these 3 still shots, right? That at the end, what happened was the water from the sphere filled up 2/3 of the cylinder. So if the volume of the cylinder is pi r squared h, then the volume of the sphere is 2/3 of that, okay? Now, this is all well and good, but instead of putting h, we can actually simplify it a little further. So if we look at this shot right here, okay, where it's, let me make it a little bit bigger, where it's showing you that the height of the cylinder is the same as the height of the sphere, essentially, right? This horizontal thing is, this horizontal plate right here is showing you that they are the same height. Well, if this is considered the height, and let me actually write in yellow, if this is considered the height of the sphere, then what is this right here? Well, in a sphere, this is the radius. So right here, this is 2 of the radius, right? It's the diameter, or 2r. So instead of putting the height here for the volume of a sphere, it's a little easier for us to replace this h and instead put 2r in its place. So let's see what we have here. We have the volume is equal to 2/3 times pi times r squared times 2r. Well, we can clean this up a little bit, okay? Let's pull this down with it. We can clean this up a little bit by combining the r. So if I have r to the first power and r squared, that's r cubed. And let's bring the 2 and multiply it by the 2/3. So we have v is equal to 2/3 times 2/1 times pi times r cubed. Well, this would be 4/3, right? So volume is equal to 4/3 pi r cubed, all right? And that is the volume of a sphere. So all 3 of the volumes together is, we have the volume of a cylinder, which is pi r squared h. We have the volume of a cube, which is 1/3 of that. And the volume of a cylinder ends up being 4/3 pi r cubed. okay? And this was just before I multiplied it out. So here are our three volumes. Each one of the cone and the sphere is derived from the volume of the cylinder. And the cylinder, you know, is derived from the general formula for prisms. Okay, now let's practice our use of this formula. Okay, so here we have the volume of a cone, and I want you to round your answer to the nearest tenth. Okay, so we have two cones here. One we have a radius of, and one we have a diameter of. All right, so remember, it's always good practice to, let's make them a little bit smaller. It's always good practice to write the volume formula down. So here, volume is equal to 1/3 pi r squared. This also helps you in order to memorize them. If you're always writing them down, it's a little easier to memorize. So it's 1/3 pi r squared. Whoops, I forgot h. So we have 1/3 pi, and we have 2 squared times the height, which is 8. Okay. So we have 2 squared is going to be 4 times 8 is 32. So we have 32 times 1/3 times pi. So this is 32/3 times pi. Okay, now we can get our calculator out and determine what this is from the calculator. If they asked for the volume of the cone in terms of pi, then you would just give this answer right here, right? Actually, you'd add inches cubed because they gave you inches, so you have to put the unit in. So I actually should have included that. But if they want it rounded to the nearest tenth, then you need to bring out your calculator. Okay, and in order to do this, let me clear out what we had before. Let's pick up a fraction right here, right? So actually, I have it in classic, so let me go back to math print because that's a little easier to understand. Oh, actually, I have to do it in classic because I don't want the pi there, so I have to keep it in classic. So if it isn't already in classic, go ahead and put it there. And let's see, I want 32 thirds. And I want to multiply that by pi, okay? And it's going to be, and you know what, let me just make sure, because I don't want it to have multiplied 3 times pi and then taken 32 and divided it by that. So 32 divided by 3 is going to be this. And if I multiply that by pi, remember, always use their pi key, I would get 33.5 inches cubed. Okay, and so we asked you to round it to the nearest tenth, and that's what your answer will be. Inches cubed. Whoops, I just have to do in cubed. Okay, for the next problem, I'm given a diameter. So if volume is equal to 1/3 pi r h, then what I don't want to think of this as 8, I want to think of this as 4 feet. So I have volume is equal to 1/3 pi, r squared. I got to be careful. It's the second mistake I've made. So 4 squared times 9. So we have 4 squared is 16. So actually I can just put this all into my calculator. So I have 1 divided by 3, right? Times pi times 4 squared times, whoops, and you'll notice I'm still up in the exponent, and this is what happens in classic print, is that you, it doesn't automatically go down from the exponent. I have to press the right arrow key, so times 9, like this, and my answer is 150.8 because I want to round to the nearest tenth. So 150.8, and that's going to be in feet cubed. Okay. Now, if I had to use a volume of a sphere, so remember, volume is equal to 4/3 pi r cubed, right? Not squared, but cubed. And so volume is equal to 4/3. What's nice about a sphere is that you only have to have one measurement, which is the radius. You don't have to mess with the height because you know the height is just 2r. And that's already taken care of in the formula. So we have 2.1 to the 3rd power. Let's go ahead and grab our calculator here. So we have 4 divided by 3 times pi times, and it was 2.1 cubed. 2.1. Now there isn't a special key to get the exponent of 2, so I have to use the caret key and bring this to the 3rd power. And again, it doesn't look as nice because you're in classic, you're not in math print. So our answer is 38.8 if we round it to the nearest tenth. So volume is equal to 38.8, and it has to be in centimeters cubed. Okay, and just like this one, we are not going to look at the diameter. We want to make sure that we're not fooled by that. We're looking for the radius. So we have volume is equal to 4/3 pi times 3.5 cubed. Okay, and if they ask for it in terms of pi, what you do is you'd multiply the numbers all together and leave pi. So you'd go 4 divided by 3 times 3.5 raised to the third power. Okay, and it would be 51.2 pi. So you could put 51.2 essentially pi if it was in terms of pi. But again, if you're asked for it, if it doesn't say in terms of pi, like up here the directions doesn't say that. So I want to actually go ahead and take this and multiply this whole answer by pi. Notice that when you hit the multiplication key, what your calculator does is it actually brings down the answer from before and multiplies it by pi. This is actually a nice way of getting a more precise answer. So you don't want to put in your calculator 51.2, because if you multiply it by pi, you've estimated the 51, or you've estimated the 57. Right? And then you've estimated, well, you haven't estimated the pi, but since you've estimated the 57 to 57.2, not 57.1666 repeating, it's going to compound any mistake that had. So it's going to compound the imprecision that that estimation created. All right, so our estimation is 179.6. And you know what? I've been really sloppy about not changing these to the approximation. So these should actually have been approximately equal to. So please go back and change that for your slides. So I have 179.6. And that's in centimeters cubed. And that's it. That's the end of the lesson for today. So it was just learning about the formulas and practicing them using our calculator.